Hi, I'm Joseph Tharkin of Brock Science Harrison, and today I'll be doing a chemistry problem. It's going to be very theory-based and it's going to be very long because it has 4 parts. So let's get started. 5 identical balloons are filled to the same volume at 25 degrees Celsius in one atmosphere with the pure gases carbon dioxide, water, helium, nitrogen, and methane. And the first question is, which balloon contains the greatest mass of gas? And explain. Well, this is a simple question because you know that by Avogadro's law, that any identical volume of gas with the same conditions of temperature and pressure has the same number of moles, which we'll call N. Now, to find the mass, you have to multiply N by the molar mass to determine how much the total mass is. And for each of these gases, they each have different molar masses, so you have to determine which one has the highest one. For CO2, N, you have 12 grams per mole of carbon and 32 grams per mole because there are 2 times 16 grams per mole of oxygen. So that is 12 plus 32, which is 44. 44 N for carbon dioxide. For water, it's 2 grams per hydrogen, so 2 plus 16 grams for oxygen, 18 N. For helium, it's just 4 N, because helium has a molar mass of 4. For nitrogen, it's 2 times 14, so 28 N. And for methane, it's 4 times hydrogen, so 4, plus 12 for carbon, so 16 N. Now 44 N is clearly the highest, which corresponds to CO2. So CO2 has the greatest mass of gas, and is your answer. So compare the average kinetic energies of the gas molecules in the balloons and explain. Well, you know that the average kinetic energy of a gas is simply the temperature, and because they told you that all the balloons have the same temperature of 25 degrees Celsius, you know that they are all the same in terms of kinetic energy. So the answer is that they are all the same. Which balloon contains the gas that would be expected to deviate most from the behavior of an ideal gas, and explain? There are 2 factors that would cause the gas to deviate from ideal behavior. High intermolecular forces and high molar mass. However, intermolecular forces doesn't really come into play because the gas particles are so far apart from each other that they can't really interact. So the only factor left is a high molar mass. We already calculated which gas has the highest molar mass, CO2. So it's clear that carbon dioxide will deviate the most from ideal behavior. And finally, 12 hours after being filled, all the balloons have decreased in size. Predict which balloon will be the smallest and explain your reasoning. Well, the answer is that's the question of Graham's law of diffusion, which states that a lighter gas will escape faster from the same container than a heavier gas will. And because helium is the lightest gas of the 5 choices, helium will escape from the balloon fastest and its balloon will be the smallest. Thank you.